go. All right, good afternoon, everyone. Welcome to the Hackers and Hero Guide to the GCP Google Cloud CLI. Welcome. A little bit about me. I am a senior red team consultant. I am from Mandiant, which is now part of Google Cloud, and I work in the Google public sector part of that. So lots of acquisitions happening, but yeah, so I'm a senior red team consultant. My day job is delivering red team and penetrations test services, all of which are listing up there. But I'm also the GCP service line owner, so it's my job to lead the development of the GCP pen testing service line. I have led this from scratch, both on the technical side and the business side of it. And most importantly, this is my very first time here at BlackAlps. So I'm really happy to be here. It's also my first time in Switzerland. And I must say, I am very, very impressed with BlackAlps so far. This has been phenomenal. This is a very interesting talk with it being one track, and everything's been very, very technical. It's very different than a lot of the other conferences I go to and see a lot of, business things and people selling products and stuff like that. So this is a really cool thing, and I really appreciate being here. And yeah, just want to give a big hand to the organizers because this is awesome. So some background on this talk. Like I alluded to, my job is to perform red teams and penetration tests on a day-to-day, but I like to think of it as research because I don't get to do a lot of research at work. I did a lot of this in my free time, but every time I go into a GCP test or any test in general, I always try and learn one new thing, and I always try to research what is going on next. It makes me feel fancy. The inspiration for this talk in particular, I started doing some tests for zero trust environments. And I was a total hater of this when they were like, you're going to do a zero trust test. I thought, zero trust is just another buzzword in security. It's just something that people are using to sell more things and create more budgets for more things. And this isn't going to take off at all. Like, okay, a zero trust environment, whatever, who cares? But actually it did slap me in the face, did kick my butt. The zero trust environment that I tested was actually one of the best GCP environments that I did, especially because this was a rare test where we got to sit and recommend remediations and watch them happen on the fly. So I would recommend a fix, and then I would allow them to fix it and re-attack. So it was a pretty cool test, and the thing that I was most impressed with was the limitations at the end on G-Cloud CLI. Every single test that I do, I steal credentials and I log into the client's environment from an external host and I exfiltrate data, every single one. So I began to wonder after this test when I actually saw these improvements and these, configurations that were kicking my butt. I began to wonder, what if we start to lock the front door? What if we start to lock the front door again and again and again? How many different defenses are possible for the GCP CLI to make it more locked down? Could we stop attackers from using stolen credentials, lock the front door, and then worry less about things like privilege escalation once you're inside? So I started to research this a little bit in my free time just to get a better understanding of it. As an attacker with stolen credentials, I interact with GCP in a few ways. There are a number of public resources that sometimes I don't even need credentials to interact with. A lot of them are listed here with their different APIs. There's also the Google Cloud Console, which you can log into with your user credentials. There are REST API calls. If you do have an access token, you're able to perform actions with an API call. They are a little bit annoying because you have to configure them a lot, but thankfully there is the GCP Google Cloud CLI, which is a Python tool suite such as gcloud, gsutil, and BQ that you can use. The different ways that you log in to the G-Cloud CLI is that you use your IAM credentials, you use application default credentials, you use service account keys, and you'll also use access tokens. And the G-Cloud CLI is essentially a wrapper for GCP API calls. So all of these things produce a access token, which gets wrapped up and used by the G-Cloud CLI to do those access calls. I'm also a heavy memer. There hasn't been a lot of memes in these presentations so far, but usually you laugh when there are solid memes on the screen. So yeah, thank you. Anyway, yeah, so when we go through all of these different things, let me show you how it's done. So we have the user credentials, which use gcloud auth login, and it goes to the browser session that you currently have on your host, and it logs you in. If you have zero trust implemented here, like I did not in this demo, you will see that you have to reinsert your password, and hopefully you do MFA. But not everyone has that. So sometimes you just do gcloud auth login, and it will automatically use the session that has already been authenticated to in the back. When you do that, the directory config gcloud fills with two very important files. So there's access tokens database and credentials database. Credentials database has components that are required to request new access tokens. The access tokens they last about an hour, but in general, your session is going to be by default at least 16 hours. And so these credentials database makes it so that you don't have to enter your password and MFA and what have you every single hour that the access token expires. There's also access tokens database, which contains the access token for the authenticated user, as you can see here. This is what is referenced by the API call with the gcloud command. Whenever I, an attacker, find one of the access tokens, I know I am pretty happy with my day. And so I go to the Google Cloud API.com/tokeninfo to find more information about it. I always look for, you can see up here, there's the email, which has the username. There's the expiration time, so how long I have to do my damage as a red teamer. And then the scope of permissions for the token. I'm usually looking for that cloud platform token, which has the full permissions assigned to it that the user has. So sometimes you'll see the scope is a little bit lower, and it will just have, like, you can list storage accounts or storage keys. But in this, you can do the full scope of the permissions that are applied on the user. So always looking for that cloud platform. For application default credentials, it makes it easier for you to run apps in different environments. It's supposed to be in your code so that your code can automatically authenticate and run things smoothly. You can see that there's a very similar authentication method as logging in with your user credentials. You just do gcloud auth application default login, and it uses the browser session that's on the host. These are not intended to let you run commands from the gcloud CLI. You're supposed to just get this JSON file, and insert it into your code. And so the JSON file looks very similar to the credentials database. It has a refresh information that you can use to get an access token, or that really your code should be using to get the access token, not you, an individual user. So when you try and use it, it's sitting in that config directory, the way that access tokens database and credentials database was sitting in that config directory. It does not allow you to interact with gcloud normally. You can see here, I tried to list the different sessions that I had, and none were there, and I tried to list the projects, and none were there. But if you just go in and change your environment variables, you are able to then authenticate and start running commands using the gcloud CLI, which makes things just a little bit easier. So that's always fun. Next, we have service account keys, which I do love because I get to play with them oh so much. They are my favorite. By default, service account keys do expire in the year 9999, which I hope to live to and continue using them by then. But essentially, they never expire. And then you can't set up multi-factor authentication on them. It's not something that's possible, nor something you would want to do, because really they're supposed to live in code somewhere and be automatically doing things. No humans should be really interacting with them. The logging on them is a little bit less verbose than what you would do if you were using service account impersonation in the gcloud CLI. When you use impersonation, it always shows what user is doing the impersonation, but when you use just the key, it just shows you the service account name. It doesn't show you that user and the service account attached. So you have to do some more digging to do that sort of like incident response on it. And then Almost always they're more highly permissive than the user that you originally start with. More than often than not, they are owners, which is great. This is what service account keys look like. Please do not hack my organization, but this is what a service account key looks like. It's a JSON file. I'm always looking for private keys, and it has the information that's needed to authenticate as the service account, which is super easy to do. You just run gcloud auth service account with the key file, and then you have logged in, guarantee no MFA. Super easy. When you do this, a new entry will be added to your Access database containing the access token for the service account. So you can see that there, and you know that it is working. And then access tokens are the last credential that we're going to look at today. So if you discover an access token, then you can set the access token as an environment variable, which we do here. And then you can start to run your gcloud commands normally. This won't show up as an active session for gcloud auth list. So if you're a red teamer watching this back, don't try it and then run gcloud auth list and be sad. Go ahead and start running your commands, and you should be able to do this. In the demo, you can see that I'm taking the access token from the Cloud Shell environment and moving it to an external host, my local host, and running it that way. This is super easy to do. You just run gcloud print auth access token. So whenever you have a session, you can print an access token, which essentially takes it from the database, and you can run it that way. So if an attacker gets any of these items, they can authenticate to the CLI, and you don't necessarily have to re-authenticate. For instance, if you find the config directory we talked about that has those databases in it, you can zip it up and then send it to your attacker host in whatever mechanism you may want to. You can just email it over if you have access to that. And then on your attacker host, you delete the current gcloud folder that you have so that your old sessions are gone. You unzip the new one that you had just stolen from your victim host. And then bam, you've authenticated to the CLI. Even if MFA was configured on it, you would have that full access. In this one, it has the service account key active right there. So a service account key was used to authenticate as that service account that's there. And that you don't need to steal the actual service account key. You just steal that directory and you're able to authenticate. So all you have to do is set your account from there, and you can run commands normally, and you are all set. With Cloud Shell, it's similar, but they did adjust some things. So now instead of config gcloud, it's in the temp folder. So you have to go into the temp folder and steal it. So if you are a red teamer watching this and you don't find that config file, go look for temp. And it's the same deal. You just zip it up, transfer it out. There's a little download button in Cloud Shell. And then add them to your attacker host, and you have to do a set account, but you are all set. So you're all set with the gcloud auth list, and then you config set your account, and you're good to go. Once you have that account, you have the valid session, but the Cloud Shell sessions are a little bit shorter, and it doesn't have that same refresh that a normal config directory would. So where do we actually steal these credentials? I have a 100% success rate on stealing these credentials on assessments that I've been on, usually because I have some sort of user account already, whether that's through social engineering or through an assumed breach test where we are given an account. We do have these credentials, but almost always we seem to go out and find these credentials as well. So where do we do that? On assessments that are internal assessments, meaning we're on-prem, I tend to steal credentials mostly from hosts. So I'll target a developer host, I'll go there, I'll find those config directories, and then I'll take them to my external host. I'll also look through the file shares, and I will find it using Snaffler. It does happen a lot. And we use that to pivot into the cloud. I'll also, if I'm on a GCP test, I'll look into the cloud hosts. So I'll look at Google Compute Engine, I'll look at Cloud Shell, I'll look at GKE, I'll look at cloud workstations. I'll find that config directory and I will take it. They're also in the cloud drives or in SharePoint. There's always credentials there. A lot of times they're in cloud storage. Sometimes they're in private code repos, and sometimes they are in public code repos. And so it's really fun to find these credentials everywhere. Finally, they're in the resource metadata, so I'm sure some of you are familiar with the fact that if you are on a GCE host or an App Engine host, or you're working with cloud functions, you can query the metadata and get a service account access token that you can then take to another environment. So yeah, a lot of places that you can get credentials from, which can be a little bit concerning, but that is why I'm a red teamer. Being a red teamer is super fun. You get to do all these things, and there's a lot of avenues, and it's just great. And I had so much fun doing this research, but the rest of this research, as I said, is the defense, and there's a reason that I don't do defense. It is very hard, and anyone who is doing it is so important to this world, and you were doing the good work, so very, very thankful. But yeah, I did learn a thing or two about defense on this and gain more respect for it. So first of all, Google has some great documentation on this attack method and how to respond to it and how to detect it and how to defend against this. So if you leave here today and you're a Google Cloud user and you want to go implement this or look into this after this talk, please go look at the best practices for mitigating compromised OAuth credentials from Google Cloud CLI. And you can get like a walkthrough on this. I did not write it. Someone very smart wrote it, but it's great. So first of all, as defenders, let's look at stopping this steal. So first of all, if you can, you should get rid of your service account keys. Like I said, they don't really expire, no MFA, highly privileged, and less logging than what would be used in impersonation. So no service account keys. Google has some documentation on when you should be using a service account key and when you should not. And then they also can help you look through and find the different methods for doing that. If these credentials do exist in your shares, which it does seem very likely that they do, you should probably start to audit your shares regularly. Not just for G-Cloud credentials, but for all credentials. You should do regular audits if you need a free tool for that. Snaffler is a good one. Trufflehog is another good one. But yeah, look through your shares and try and find credentials that exist, because that's what I'll be doing. For DLP, for data loss prevention, you should try to stop these things from leaving your environment in the first place. So I was pretty shocked to see this, but Chrome Enterprise does have something that has DLP. If you go in and you put these DLP rules, you'll be able to block the download. This is a screenshot of me being blocked from downloading the credentials on a test. So next, privilege access workstations. So if you want people to stop putting credentials all over your file shares, you should limit them to a specific privilege access workstation. So if you create a dedicated restrictive workstation to perform their sensitive tasks, then they won't be putting their credentials on file hosts and on shares that I can get to. You can also create a VPC service control. If you have a VPC service control, then you'll only be able to use the project and interact with a GCP project if you're within that dedicated VPC service control. So think, if I steal those credentials and I start to try and download all of the bucket objects from your environment, there should be a pop-up that says you're not in the VPC that's allowed to touch buckets in this environment, therefore you cannot continue this attack. So that's something to consider. Chrome Enterprise also has a way to force authentication from very trusted devices. So yeah, if we can pretty much allow list and create this like zero trust mindset of if you're not supposed to be here, you're not allowed to do these attacks, then that can really help mitigate them and mitigate the stealing of all those credentials. To stop the actual authentication, because the stealing of the creds does seem kind of likely where we're at, you can try VPC service controls again. So if they are going to authenticate, because if the credential is stolen from the environment, that session is going to be valid for at least that hour. Then if they're on that other host with that session, with that access token, they can't actually do anything with it if they're not in the VPC and if they're not on a trusted device. So again, setting up these things that I've already talked about is really important. Also session times. So like I said, there's a 16-hour default on this. If you go in and you set up both Google Cloud session times and Google session times, you must do both. You can lower that to what's appropriate for your developers. Perhaps it's 4 hours. Perhaps maybe it is 1 hour. Maybe you hate them. But yeah, it doesn't seem too harmful to lower it. And then finally, we have multi-factor authentication. So soon by default, all admins, anyone with an admin permission will have default MFA, but you should really be going out there and putting MFA on all of your users and all of your guest users in the environment. And then detecting suspicious activity. So once these credentials are outside of the environment, you're going to need to detect what's going on. So if they are going from a IP address that isn't known, or they are doing suspicious activity that they're not normally doing, for instance, a service account is supposed to be doing routine actions. If they are instead creating more service account keys, you should be able to detect that and then take away that. If you do any of these, you should always revoke the current sessions that are happening so that those mitigations can be fully implemented. So make sure you revoke before doing that. In summary, defense, you are rock stars and you can actually kick my butt. All of these are possible. It is possible to stop both the stealing of the credentials and stop the damage if they are stolen. So I truly believe as we move forward through zero trust and through moving more towards cloud, from what I've seen, having tested all those environments, both on Windows and in cloud, you are going to make it way, way harder for attackers. It really is possible to mitigate all these things. And if you're a red team or going up against these things in a zero trust environment where all of the defenses have been put up, well, I'm sorry, but you'll have more time to do research, which is very fun for you. So that is it. These are some resources. We are good. We have 10 minutes for questions. I did expect more laughs but so I had so a little bit shorter time, but yeah, lots of question time.
Thanks a lot, Shannon. You are better than Swiss time. So we have time for question. Please don't be shy. We have time. There's one here. Alexandra. Yes.
Thank you for the talk. I would like to know if there is some specific detection of use of credential extracted from other environments. So, for example, if you extract an access token somewhere, is there any detection if you use it on your own computer, or should you use on a specific cloud infrastructure?
Sure. So I am not sure about the default detections that are in SecOps, formerly known as Chronicle, but if you are using an access token and you're in another environment, then the action in logging should show that you're coming from an IP address that isn't known, and that should pop up in Chronicle, I think.
Okay, thank you.
Pretty sure.
Anyone else? Any other question? Yes, here in the middle.
Yes, so I had a question was maybe more related to general sysadmin than just DevOps environment, but do you think this can extend, in fact, to sysadmins like, cloud sharing session and every tool of work that can be used via cloud?
I'm sorry, I couldn't quite understand.
So I was asking if what we were shown here could apply to the sysadmin in more general ways when we use cloud services.
Oh, could this apply to more ways than cloud services? Yes, this could apply to more ways than cloud services. So there are different types of credentials that you can steal from like traditional on-prem environments, but in general, creating a zero trust environment, creating dedicated work hosts, and setting up everything so that it's allow listed and MFA is really where we should all be at by now, I think.
There's a question here on my left.
Thanks a lot for your talk. I had a question with regards to detections. So you mentioned how to attack. You mentioned how to prevent. Do you have any insight that you might be able to give in terms of setting any detections up in developer workstations that might tie into a SIM, for example?
Yeah, so Google has the SecOps, formerly known as Chronicle, which has built-in detections similar to this. I don't know all of them off the top of my head, or many of them, honestly. But in general, if you have a custom SIM and you're looking to set up detections for it, I do recommend, first of all, in DLP, for instance, if someone is going to download these things, that can be a detection. Why are they downloading the directory? And then in general, if a service account key is authenticated with, that should be a detection. And then if service accounts are doing actions that they are not doing normally, that is something that should be detected. So usually it's looking for suspicious behavior or actions being taken from unknown environments that I would be looking for.
Thank you for your talk. I have a question too. Is such credential can be found on a Windows machine? Is there a CLI client for Windows?
The G-Cloud CLI is also available on Windows, so these credentials are taken from Windows machines as well.
There was another question there. Yes. It's just...
Hello, thank you for your talk. With the massive spread of AI assistants, have you ever find a way to extract credential from AI assistant suggestions such as GitHub Copilot?
Yeah, so I haven't been able to do that from any of the major ones like ChatGPT or Gemini or Copilot, but there have been some, more custom AI credentials that Mandiant has stolen credentials from.
I saw a hand up here. Yes, thank you.
Thanks, Shannon. These config files and the credentials are stored in SQLite files, right? It's in the config directory, the ones that you were showing.
Yeah, they're stored in the config directory.
Yeah, correct. Is a kind of SQLite files and databases?
Yes.
And isn't that, or can be for mitigation, is encrypted or password accessed by just on the process for the G-Cloud? Or maybe workaround solution to...
Yes, so the process does contain access tokens from the SQLite database.
Yeah, just collecting these and sending by mail or just to your host. And
I am not aware of the encryption mechanism that it is using, if that is the question.
No. Just by decompressing the files and then collecting all this data from encrypted SQLite file is...
Oh, I have not tested it on an encrypted file.
Okay.
That's a good test, though.
Yep.
There's maybe a last question here, just on your left.
Thank you for the presentation. Nice memes. To come back a bit about service account keys, what is the legitimate use case of this kind of credentials? Do you see them often? And can you generally avoid using them as you recommended?
Yes, so I do see service account keys in every single environment that I am in, but as people become more mature, I have started to see less of them. So the ones that remain are usually service accounts that are being used, service accounts in general I'm seeing less of, but the ones that are staying are used in Terraform to set up the entire environment's infrastructure and permissions and to manage those permissions consistently. And so sometimes there are service account keys there, but there has been a decrease in them. I think as more people work with their security engineers that Google does offer, they are finding different solutions.
Thanks.
Very last question here in the middle another time. Thank you.
Thank you for the talk. Really funny too. You said that you identify stolen credential in code repositories. So which kind of credential did you find in public or private repositories, and how do you manage to use them?
So the types of credentials that I find are mostly service account keys, and we use them just like I showed, just gcloud service account auth key, and then start doing actions from there.
All right. Thank you again, Shannon.
Thank you.